Now let's look at carbon plus oxygen giving us carbon dioxide. So you guys know about the compound identification. Let me not go to that. You guys are familiar with that. Let me go with the reaction. So how do you do this? Balance the equation. First, we'll make a small table. We'll write all the reactant and the product at the top. Again, this is a method. You guys can use any method. We'll list out all the atoms which are part of the reaction. And then we'll count. Ca is 1 over here. There's no oxygen. In O2, there's no carbon, but there is 2 oxygen. And in the reactant in CO2, we have 1 carbon and 2 oxygen. Clearly, this is balanced, and so it's done, right? So finally, we'll write it as carbon in solid form. And then we have oxygen in, yes, gaseous form. When we supply this with heat, we will get CO2, which is a gas, plus, yes, important thing, heat. That's the basic funda. So it's quite simple. How do you get to know that the reaction is happening? Correct. Heat being released. So this is an example of exothermic reaction. Exothermic reaction. Next, we also have light being produced. And we have, what else? Formation of gas. That's enough. Okay. Again, this is a bit out of syllabus, but let's discuss what exactly happens. What kind of bond are we looking at? So carbon, obviously it has to be what? It has to be covalent bond. Polar, non-polar? Non-polar. O2 is also covalent bond and they are non-polar. Non-polar. So we need an external source to break the bond over here. So external heat is required to overcome the attractive energy and start breaking the strong bond in oxygen molecule and disturb the carbon lattice as well. That is structure, right? So oxygen, the heat makes it, get radicalized. I don't know if I should be using that term with you guys. And then it leads to basically it combining with carbon, and end of it we get carbon dioxide. So I'll keep it very simple. If I go to the detail, then it's going to be difficult for you guys. So the bond that is produced are significantly more stable and they are at lower level energy. Let me at least tell this. See, CO2 is at lower energy and you have your C plus O2 at higher energy. In your reaction, this is the direction of flow. From higher energy to lower energy and more stable scenario, it's moving from higher to lower. So there is difference in energy, and this will come out as, this will come out as heat. As simple as that. Okay, guys. So this is also a very simple equation.